type inequality problem, and you know that in this type of programming, you rewrite this constants like some constant a1, x1, a2, x2, and this is here. This is because this of lesser equals to type. So here we introducing some slack variable. Okay, so that equals to something bi or b1, b2, whatever you want to say. Here. Okay, so here if your initial feasible solution. So for initial feasible solution here, what is your s1? This is your slack variable. This is your slack variable, and that select variable has property which is either greater or equals to 0. Okay, so now here for initial feasible solution, for initial feasible solution, initial basic feasible solution. So here if we try to find what is our initial basic feasible solution, that's why if we putting here x1 and x2 that equals to 0, so here we put x1, x2 that equals to 0. So we get here your s1 is equals to bi. Okay, so if your bi is suppose less than 0, okay, so in that case if bi is less than 0, so your s1 is negative 1. Okay, so if this is negative, so you get your result is this s1 is greater or equals to 0, but here you get this as a negative 1. So this implies this you get here your s1 is infeasible solution. Okay. Okay. And suppose on the other hand, if our problem is of type greater or equals to type inequality, suppose if our equation is simple one equation, we can write here. Suppose this is greater or equals to something b1 or bi, whatever you want to write here. Okay. And here your x1 and x2, of course, greater or equals to 0. So in this case, you adding here because this is greater or equals to sign. So that's why you introducing here surplus variable, so that why this equals to b1. Okay, what is your s1? This is greater or equals to 0, and you know that this is your surplus variable. Okay, so to make this inequality. Okay, this is to this constants in your in standard form. Okay, so now here if for initial basic feasible solution, for initial basic feasible solution, you get here your s1 and x2 that equals to 0. So this implies you get here minus of s1 equals to b1. Okay, and suppose in that inequality, in that type of inequality, if your pi is suppose greater than 0, okay, so this implies your s1 is equals to minus of b1, and that equals to negative 1. Okay, so in that sense your s1 is infeasible. Okay. So here you, in that case, you also get your infeasible solution. Okay. So this means either your inequality, if your inequality of type, suppose any inequality, suppose summation that I is from any 1 to n, a, I, j are your options, and suppose there are n decision variable and there are some m number of inequality constants, suppose 3j. Okay, and here xi is greater or equals to 0 and j is varies from 1 to m. Okay, so these are m number of inequality constants. So if this type of inequality constants or this type of inequality constants, there are two types of inequality constants. If this bj, if this bj is positive one, then no problem. Then no problem. You have simply introducing slack variable, and that is value equals to something positive value. But if the lesser equals to type inequality and your bj is negative one, in that sense, after introducing, you get your slack variable is infeasible solution. And on the other hand, if there are greater or equals to type inequality, greater or equals to inequality, and if this bj is negative, if this bj is negative, then no problem. Your slash surface variable has positive value, then this is feasible. But in the case of your bj is greater than 0, this is positive 1 in that sense, when this is greater or equals to sign and your bj is positive, In that case, so okay, surface variable is infeasible solution. Okay, and in less or equals to type, if your vi is negative, then you get infeasible solution. So in less or equals to inequality, if bj is negative, then you get infeasible solution, and greater or equals to inequality when bj is positive, then you get infeasible solution. So in that case, you have to maintain that infeasibility of solution and introducing the artificial variables. Okay. So now the artificial variable and that artificial variable are denoted by AJ, capital AJ, and that are the simply that are the basically this is artificial variable basically has no meaning because there is no role in your optimization problem in either in equality constants or in your objective function. Okay, so this is artificial variable. So we have introducing your artificial variable like AJ. Okay, and this is artificial variables, and this variable has also better up to 0. Okay, so this artificial variable has physically no sense. Okay, and these are only used to as a tool for generating a initial linear programming problem solution. Okay, so now if we take a problem which is basically based on your minimization problem. Okay, so there are two methods. The first one is two-phase method, and second one is big M method. Okay, so now we let us start with the big M method first, and then we go to our this two-phase method. Okay, so okay, so now on next page, we're taking the problem of minimizing. So suppose if we take a problem that is a minimization problem, so minimize objective function, minimize objective function. Suppose your objective function is z not equals to, we write 600 x1 plus 500 x2. Okay, so this is the problem, and subject to the constants. Constants are 2x1 plus x2. This is greater or equals to 80, and x1 plus 2x2. This is greater or equals to 60. And third one is x1 x2. This is greater or equals to 0. Okay. So these are inequality constants, and this is a problem. Okay. So now we have to rewrite this problem in standard form. In standard form by using your artificial variable and slack variable like that. So what is the standard form of this problem? So here the standard form is minimize problem is minimize, okay, objective function, and that is 600 x1 plus 500 x2, and these two are decision variables, and subject to the constants. And subject to the constants, and constants are here 2x1 plus x2, and here this is greater or equals to sign. This means you have to introduce here surplus variable. So this is so minus of surplus variable. Okay, so this is minus of s1, and you know that if your inequality of greater or equals to sign and your b is positive one, then in that case, if we only introduce surplus variable, that is this gives you infeasible solution. You know that. Okay. And in less or equals to inequality, if this is your negative one, then in that case also you will get your infeasible solution. So uh, here we have to introducing an artificial variable to maintaining that infeasibility. Here we introduce first artificial variable, that is s1, that equals to 80 here. Okay, so no problem here. If you setting x1 x2 equals to 0 here, s1 equals to 0 here. So if we not introduce a1, in that case x1 x2 equals to 0, you get x1 equals to minus 80. So that is your infeasible. So that's why we introduce here an artificial variable, and now this minus this equals to 80. Okay, so no problem. Okay, whatever the value of okay, so these two are positive one, s1 is greater or equals to 0, and a1 is also greater or equals to 0. And if this minus this equals to 80, this is possible. Suppose if we take a1 equals to 100 and s1 equals to 20, both are greater than 0, and then this minus this equals to 80, so this is still good. Okay. So now similarly for second one is x1 plus 2x2, and here we introduce another variable, and in same sense this there is a greater than, so in that sense we introduce another artificial variable that equals to 60. Okay. So now there are s1 s2, there are two surface variable and two artificial variable. So in that case your x1 x2 and s1 s2, and there are both e1 and e2. So there are now these all are the type of zero. So in that sense, if there are n number of variables and n number of equations, so now there are n plus 2m number of variables. N, this is n, and this is 2 times of n. This is 1, 2, 2 into 2, 4 plus 2, 6. There are 6 number of variables. Okay. So now, here, now these are your S1, X2, S1, S2, and even A2. These are 6 variables. So your minimization problem is also written in this 6 question. So here, these are basically there is no role in your objective function. That's why we introducing by the zero cost of that 0 S1, 0 S2, 0, and this is a method of not only two-phase method. So this is we first solve big M method. The big M method to solve this minimization problem. Minimization problem. Okay, so in from this big M method is also for minimization and also for maximization problem. Both type of problem you can solve it. Okay, so maximization problem. Okay, so here, this minimization problem or maximization problem you can solve by using big M method. Okay, so now we have to cost of that big M means we have to assign the cost of this artificial variable is a big M. Big M in sense this cost is M, and this M is very large. M is in the sense of very large. Okay, so M of E1 and M of A2. So this is your objective function. Okay. So now here we get the initial basic feasible solution. So now the initial basic feasible solution is obtained by we have to set this all x1 x2 s1 s2 that equals to 0. So if we put in here all this equals to 0, so we get here, we get, if we setting all that, we get what is the value of artificial variable a1 that equals to 80, and what about a2 is 60. Okay, so we get this thing, a1 is 80 and a2 is 60. See, so what is the value of given is 80 here and this is 60 here. So what is the value of z here? If x1, x2, s1, s2 are 0. So in that case, your value of z is z is equals to 140 and okay. So now we construct our initial table, and that initial table is this is Cj.
सर
हाँ
सर ये जो ऑब्जेक्टिव फंक्शन है मिनिमाइज जेड में, सर ये जो आपने प्लस ma1 प्लस ma2 लिखा, सर यहाँ पे तो माइनस ma1 माइनस ma2 होगा।
कहाँ पे?
सर ये जो ऑब्जेक्टिव फंक्शन नहीं है मिनिमाइजेशन ऑफ जेड इज इक्वल टू, सर जो ये आपने ऐड किया आर्टिफिशियल वेरिएबल्स में, तो सर वहाँ पे तो माइनस a1 माइनस ma2 होगा।
क्यों क्यों ऐसा होगा?
मतलब जो ग्रेजुएशन में पढ़ा तो सर आर्टिफिशियल वेरिएबल में सर जो उसको कोफिशिएंट हम लोग ऐड करते थे ऑब्जेक्टिव फंक्शन में, सर वो माइनस हम ऐड करते थे।
वो माइनस साइन में होगा?
यस सर।
इन मिनिमाइजेशन टाइप ऑफ प्रॉब्लम और मैक्सिमाइजेशन टाइप ऑफ प्रॉब्लम?
सब बोथ, दोनों में यही पढ़ा था।
दोनों में यही पढ़ा था?
यस सर।
ओके, अब बेसिकली बहुत से मेथड्स हैं और डिफरेंट डिफरेंट बुक्स भी हैं। और अब उसमें ये है कि ओके, अब इसमें ये है कि आपकी प्रॉब्लम जो है हम उसी मेथड से चलते हैं, जब दूसरा मेथड नहीं यूज करते। ओके, जैसे आप कांतिश रूप पढ़ेंगे, उसमें अलग है CJ माइनस ZJ का ऑप्शन। किसी में वो निगेटिव लेके चलते हैं, किसी में पॉजिटिव लेके चलते हैं। हालांकि एल्गोरिथम प्रोसेस सेम ही है, प्रोसेस सेम है, उसमें कोई दिक्कत नहीं, बस तरीका अलग है। पॉजिटिव निगेटिव अगर हम उसको रिवर्स कर दें तो आइडिया हमारी रिवर्स हो जाती है, तो कुछ नहीं। ठीक है,
ओके सर, ओके सर।
और कोई बात नहीं है, कोई बात नहीं, आपने जो पढ़ा है उसी पे हम चल रहे हैं। चलिए, क्योंकि डिफरेंट बुक्स है, इसमें सिर्फ वही चीज़ कॉन्सेप्ट यही है कि सिर्फ पॉजिटिव नेगेटिव को अगर हम एक जगह बदलेंगे तो फिर बाकी मैकेनिज्म को यहाँ हम चेंज कर देंगे। ठीक है, और कुछ नहीं। चलिए, तो इफ दिस इज CJ and here if our B, that B is XB and this is your basis variable and cost of that. Okay, and here in first case your main basic variables are E1 and E2 and the values of that is 80 and 60 here, 80 and 60, and cost of that is minus M and minus M. Okay, so now because here we take the case when we take the largest negative concept. Okay, और वहाँ पे हम क्या करते हैं, लार्जेस्ट निगेटिव का कॉन्सेप्ट नहीं है, वहाँ हमारा पॉजिटिव कॉन्सेप्ट है। तो आप बेटर यही है कि आप फिर हमें यहाँ पे चेंज करना होगा। इससे बेहतर है कि आप वही चीज़ लेके चलें और मिनिमाइजेशन में आप प्लस साइन रखें और मैक्सिमाइजेशन में आप माइनस साइन रखें। तो मेरे ख्याल से ये आपके लिए ज़्यादा बेहतर होगा, और बाकी कॉन्सेप्ट आपका सेम ही होगा। Then cost of that is M, and here again M, and if we take here x1, x2, s1, s2, e1, e2, and here the equation, our first equation is 1 1 minus 1 0 1 0, and second equation is 1 2 0 minus 1 0 1, Okay, and here if we multiplying here, so the quotient of this is 600, here is 500, this is 0, this is 0, and here m and m. Okay, so if we try to find what is the value of zj, and here z equals to 140 m. Okay, so now uh, this m is very large here. Okay, so m is very large. So in that sense, if we multiply here zj cd y1, so this becomes 2m and 1. This becomes 3m. 3m. This is again 3m. This is multiplying here. This is minus m. This is minus m. And if you multiplying here, this is n and this is n. So what is the value of Cj minus Zj? If we take this equals to 600 minus 3m. Okay, and here in this sense, u value is 500 minus 3m, and at this stage, this value is n, this value is n, and here this is 0 and 0. Okay, and in that sense you have to find the largest negative. Okay, आपको थोड़ी सी कंफ्यूजन होगी आप जो वो मेथड लेके चलते हैं सीजे माइनस जेड से, जहाँ पे हम आर्टिफिशियल वेरिएबल को यहाँ माइनस साइन करेंगे ना, इफ यू टेक यहाँ हियर माइनस साइन, तो क्या होगा, बेसिकली चेंज कहाँ होगा, और आप बस देख लीजिए दोनों में डिफरेंस क्या है। हम जब लेंगे वहाँ माइनस एम, तो यहाँ पे हमारी इसकी कॉस्ट क्या हो जाएगी, ए1 की वैल्यू दैट इज 60 एंड ए2 की 60, बट कॉस्ट ऑफ ए1 इज माइनस एम। उस सेंस में आप यहाँ पे क्या लिखेंगे, आप माइनस एम लिखोगे और यहाँ पर भी क्या लिखोगे, माइनस एम लिखोगे। ठीक है, तो जब माइनस एम यहाँ भी लिखोगे, माइनस एम यहाँ भी लिखोगे, माइनस एम यहाँ भी लिखोगे। जब आप मल्टीप्लाई करोगे यहाँ से यहाँ, तो दिस इज माइनस 2m और दिस इज माइनस एम, तो दिस बिकम्स माइनस 3m, और जब आप इसमें सब्ट्रैक्ट करोगे तो दिस बिकम्स 600 प्लस 3m हो जाएगा, उसी तरह से यहाँ 500 प्लस 3m होगा। यहाँ पे क्या होगा, यहाँ पे आपका प्लस m आएगा बिकॉज दिस इज माइनस, यहाँ पे आपका प्लस m आएगा, और यहाँ पे कोई चेंज नहीं आएंगे क्योंकि यहाँ पे m आ रहे हैं, वहाँ पे क्या आएंगे, माइनस m आएंगे। जब आप सब्ट्रैक्ट करोगे m माइनस m 0 होगा, माइनस m 0 होगा, तो यहाँ पे कोई चेंज नहीं आना, यहाँ पे 0 ही आना है। बस चेंज कहाँ आएगा, जब आप यहाँ पे देखोगे तो यहाँ पे आपका ये माइनस m आ जाएगा, ये माइनस m आ जाएगा, इफ यू टेकिंग माइनस माइनस, और ये क्या आएगा आपका 600 प्लस एंड 600 प्लस। और आपने जो मेथड लिखा है वहाँ पे आप क्या करते हो, लार्जेस्ट पॉजिटिव वैल्यू का आपके पास कंसेप्ट है। ओके, लार्जेस्ट पॉजिटिव वैल्यू, बट हमने यहाँ पे क्या किया, थोड़ा सा चेंज किया है कि मिनिमाइजेशन केस में हम क्या लेंगे, लार्जेस्ट नेगेटिव, और मैक्सिमाइजेशन केस में हमें क्या लेना है, लार्जेस्ट पॉजिटिव। ओके, तो ये जो कॉन्सेप्ट है ये यहाँ पे थोड़ा सा चेंज किया है कि मिनिमाइजेशन के केस में हमें लार्जेस्ट नेगेटिव लेनी है, और मैक्सिमाइजेशन केस में हमें क्या लेना है, लार्जेस्ट पॉजिटिव। दैट्स वाई हम ये कॉन्सेप्ट लिया है। अगर आपको सिर्फ और सिर्फ एक ही रूल पे जाना है, तो सिर्फ आपको जब हमेशा आपको लार्जेस्ट पॉजिटिव पे जाना है, तो उस सेंस में आपको फिर ये यहाँ पे प्लस करना होगा, और आप फिर एक ही मेथड से आप फिर जाएंगे। ठीक है, तो क्योंकि हमने लास्ट टाइम पे हमने लार्जेस्ट नेगेटिव और लार्जेस्ट पॉजिटिव की बात की है, तो हम उसी पे ही रहते हैं, क्योंकि दो तरह से हम करेंगे तो फिर मुश्किल हो जाएगी। ओके, तो यहाँ पे आप देखेंगे तो लार्जेस्ट नेगेटिव क्या होगा, तो लार्जेस्ट नेगेटिव इन दिस सेंस, इस प्रॉब्लम में देखें तो हियर m is very large, very large in the sense that this order of m, जैसे आपके पास जो कॉस्ट है दैट इज सपोज ये 600 है, 100 में है, तो आप m को क्या ले लो, एक नेक्स्ट ऑर्डर ले लो, दिस इज वेरी लार्ज, तो सपोज m इक्वल्स टू 1000। ओके, तो m इक्वल्स टू 1000 हियर, तो सपोज m, if we take m, the cost of m is large, so if this is cost is 500 600, in that sense you take m equals to in the order of next order, that is 1000 or 10,000, कुछ भी ले लो, या तो 1 lakh ले लो, कुछ भी ले लो। तो सपोज we take 1000, okay, so if 1000, so 3 into 1000 is 3000, so this becomes minus 2400. So this becomes minus 2400. So this, if you're taking that value, this minus 2400. Okay. और यहाँ पे अगर आप देखें तो this means here minus 2500. Okay. So which one is largest? Which one is largest? तो largest वहाँ पर क्या है? minus 24. Okay. माइनस 2500 है, माइनस 2400। तो लार्जेस्ट क्या है? ये है। तो हमें लार्जेस्ट कंसेप्ट नहीं है, यहाँ पे हमने क्या किया है? लार्जेस्ट नेगेटिव। ओके, so this one is your largest negative. Okay, तो यहाँ पे this one is largest negative. So this is your largest negative. This means this x2 will enter into the solution, and this is your key column. Okay, so this means this is your x2. This first one is your key column. Okay, so now you have to obtain the minimum ratio. You have to obtain the minimum ratio, and that minimum ratio is xb, means this value over this x2, which is your key column. So now if we try to find that this is 80 over 1 and this is 60 over 2. So which one is minimum? So this is 80, and this is 30. So this is minimum. Okay. So this value is minimum. So this means this corresponding to your A2 artificial variable. So this variable A2 will leave the solution. And here the intersection of these two key column and row, so this is your key element, and you have to make this value is 1, and then corresponding E operation you make that equal to 0 here. Okay, so now your next table, you have to write x2 in this basis variable, and a2 has removed. Okay, so here your x2 will enter into the basis, and artificial A2 will leave. Okay, so now your next table is to go to next page. This is CJ. It's a list of solution values. This is variable cost, and these are the variables x1, s2, s1, s2, a1, and a2 will leave the solution. And here the variables are a1, and here x2 will enter, and the cost of that is m, and here 500. So this value is after calculating, this value is 300. This is 3 by 2, 0, minus 1, half, 1, and in second row this is half 1. This is your key element. We make that by using E operator, that equals to 1, and this is 0 minus half and 0. Okay, and the cost is here 600, 500, 0, 0, here big M. Okay. So now we calculate what is the value of Z here. So here Z equals to your x2 is 500. So in that sense, so x2 is 500, and your maximization problem is 500 into x2, and x2 500 into x2, and x2 equals to 300. If you multiply that, this becomes a 15,000, and plus m of a1. So m1 equals to 50 here. This becomes 50 m. And what is the value of zj? If you multiply here, so So this becomes Zj value is 3m plus 250. Here if you multiply here, this is 500. This is minus m. This is m by 2 minus 250. And this is m. So what about Cj minus Zj? Cj minus Zj, so 600 minus this, so this equals to 350 minus 3m. Okay, and here 500, 500, 0, and this is capital M. And here 250 minus m by 2, and this equals to 0 here. Okay, so now here we have
सर
to obtain.
जेड का फास्ट टर्म 3m/2 होगा ना?
यस सर 3/2m होगा.
This is by 2, no?
Yes sir.
Okay, okay. Hmm. So now we have to find out which is the largest negative. Largest negative means if we take m equals to 1000 here, suppose m equals to 1000 here. So this is 350 minus 3000 by 2. This becomes 1500. 1500 means this equals to minus of 1150. Okay, and here if we take m equals to 1000, this becomes minus 500, so this becomes minus 250. Okay, so this is minus 250, this is minus 1150. So this is the largest, this was the largest, but we have to take the largest negative. So which one is largest negative? So this one is largest negative. This value is largest negative. Okay, और वहां पे आप अगर माइनस एम सी करेंगे तो आपको वहां पे सिर्फ लार्जेस्ट वैल्यू का कंसेप्ट है, तो उस केस में आपको ये मिल जाएगी उस सेंस में, तो आप इस तरह से करेंगे. ठीक है, तो दोनों ही कॉन्सेप्ट है, जैसे आप करना चाहें उससे कर सकते हैं. ओके, so this means this enter into the basis. So you x1 enter into the basis, Okay, and so now if this enter into the basis, so which one is give you a solution, so you have to find the minimum ratio. Minimum ratio is here, this value is 50 over 3 by 2, and here 30 over half. This is basically 60, and this is 100 over 3, this is 33.33. Okay, so this one is minimum, this is minimum. So this means this variable a1 will leave the solution. Okay, so now for this column and this row, this is your key element. This is your key element. Okay, which is intersection of this column and row, and you maintain this equals to 1 and this is 0. Okay, so after reducing them, your table is now reduces in this form. This is Ck Pxb and basis variable, and the cost of that x1, x2, s1, s2, and a1 will leave the solution. That's why you no need to write here. And here x1 in there in place of x2. Of the cost of that cost is this cost is e1. X1 is for 600. Okay, that's why we write here 600, and here 500, and after 2 by 3, if you multiply by 2 by 3, this becomes 100 by 3, 100 by 3, and this position is 1. If you multiply by 2 by 3, this becomes minus 2 by 3, and this is 2 by 3. And similarly, after that, subtracting here. Okay, so this becomes 0, and this is 40 by 3 is 1, is 1 by 3, and minus 2 by 3, and the cost is 600, 500, and 0 and 0. And what is the value of this objective function, that is z? That is 600x1. 600x1, if you multiply here, so this becomes 60,000 by 3, and here if you multiply that, that is 20,000. 60,000, 20,000, this becomes 80,000. This is 80,000 by 3. Okay, this is a Z. And what is ZJ? ZJ, if you multiply here, so this becomes 600. This is 500. If you multiply here, so this becomes 3 to minus 400. And this is minus 1200, and this is 500. So this is the minus 700 over 3, and here 1200, and this is 2000. Okay, so 6. This is 1 by 3. 1 by 3. If we multiply by that minus 2 by 3, 2 by 3, so this becomes S2 is 1 by 3. So this becomes 1 by 2 here, so that's why this is 1 by 3. This is 1 by 3 because okay, so this column is removed A1. Okay, that's why this is 1 by 3. 1 by 3, so if you multiply here 600 and minus 1000, so minus 400 over 3. So what is the value of Cj minus Zj? So this becomes 0, this is 0, and this is 700 by 3, and here 400 by 2. This means all Cj minus Zj is greater or equal to 0. For minimization case, that is your solution is optimal solution. Okay, so you get here optimal solution. So this is your final solution, and this is your optimal one. Okay, so this is basically algorithm for this type of problem. Okay, so what is the solution is? The solution is the decision variable x1 is 100 over 3 and x2 is 40 over 3. So this is the final optimal solution, and what is the value of that is equals to 80,000 by 3. This is the final answer. Okay, so this is a problem which is a minimization case. In minimization case, we write in objective that is minus m, and we take here the largest negative. Okay, and suppose if your problem is a maximization case, so in that case you follow the same rule, that is you write in the problem as m is minus m, and you are find here not largest negative, but you have to find the largest positive. And when you stop the process, when all are less or equals to 0. ओके, तो ये सारी चीजें चेंज हो जाएंगी, ये सारी चीजें चेंज हो जाएंगी कि यहाँ पे हम लार्जेस्ट नेगेटिव की जगह हम लार्जेस्ट पॉजिटिव ढूंढेंगे, और यहाँ पे हम तब हमारा ऑप्टिमल सॉल्यूशन होगा जब दिस इज लेस और इक्वल टू 0, और ऑब्जेक्टिव फंक्शन में हम m की जगह माइनस m रखेंगे. ओके, तो एक हम प्रॉब्लम जल्दी से हम कर भी लेते हैं कि मैक्सिमाइजेशन में हम क्या होगा. दोनों में कोई कंफ्यूजन न रहे, तो हम जल्दी से एक मैक्सिमाइजेशन भी कर लेते हैं. तो suppose if we take maximize objective function, that is 5x1 plus x2, and subject to constants. Constants are 5x1, 2x2 less or equals to 20, and x1 is greater or equals to 3, x2 suppose less or equals to 5, and x1, x2, this is a mixed type of inequalities, 0. Okay, so now this inequalities can be written in the form that is you can write here 5 of x1 plus 2 of x2, and this is a lesser equal to 5, and this is positive 1. Okay, so you have to introduce slack variable only. Okay, because this equal to 20, no problem. This is a simple solution. Okay, but here if we x1 and we minus of surface variable, and we can write here that equals to 3 here. So this means this s2 equals to minus 3. This is integer. That's why we write here an artificial variable, that is a1. Okay, and here this is x2, and this is less or equals to 5 your inequality. So that's why we write here s2 variable. And if suppose this is minus 5, suppose this is minus 5, तो उस केस में हम क्या करते हैं, -5 होता तो यहाँ पर हमें फिर यूज करना होता आर्टिफिशियल वेरिएबल. But this is 5, so no problem. This is equal to 5. You no need to write here the artificial variable. Okay. So your variables are x1, x2, and s1, s2. These are the slack and surplus variable, and only one artificial variable, that is your a1. Okay. So this is all our greater or equal to 0. Okay, so your problem is maximization problem. So you write maximization of z, and your objective is 5 of x1 plus x2, and your surplus variable and flat variable. So the cost are 0, and here you introduce artificial variable, and your problem is a maximization case. So that's why you write here this of m with a1 only one. So that's why we write here only minus m of a1. Okay. Now we take here what is the initial basic feasible solution. Initial
हेलो सर।
basic. हाँ
सर ये जो थर्ड वाली इक्वेशन है x2 इज लेस देन और इक्वल टू 5, तो इसमें तो s3 वेरिएबल लगेगा स्लैक।
x2 में क्या है?
x2 में सर जो ये आपने फॉर्म करे इक्वल में चेंज किया है तो s3 लगेगा इसमें वेरिएबल।
हाँ ये s2 हमने इसे यूज कर लिया है। ओके ओके, ध्यान नहीं दिया हमने। s1 s2 s3 कर लिया, s3 तो यहाँ एक और ऐड होगी। ओके ओके ओके, ठीक ठीक कहा आपने, ठीक कहा। s3 और यहाँ पर भी s3 होगा, ठीक है। ये करेक्ट कर लीजिए, हमने ध्यान नहीं दिया ना, हम इन्हीं दोनों को लेके चल रहे थे। ये भी था s1 s2 s3, ठीक। s1 s2 s3, ओके करेक्ट कर लीजिए। ओके, and here x1 x2 s1 s2 s3 a1. Okay, so initial basic feasible solution is obtained by setting this x1 is equals to 0. Now x1 is 0, x2 is 0. Okay, so if we take here, this is x1 x2 is 0, and now these two are your slack variable, only slack variable. तो अगर हम x1 x2 में अगर हम 0 पुट करते हैं तो इसलिए हमें s1 की वैल्यू निकल आएगी और s3 की वैल्यू निकल आएगी। ओके, तो यहाँ पर सिर्फ हमें प्रॉब्लम होगी दैट इज आर्टिफिशियल वेरिएबल। तो जहाँ आर्टिफिशियल वेरिएबल है उस केस में हमें सरप्लस वेरिएबल को हमें सेट क्या करना होगा, दैट इज योर 0, s2 equals to 0. So this implies you get the initial solution is s1 that equals to 20, and what about your s3 is 5, and artificial variable that equals to 3. Okay, so from these three you have to find this is your basic feasible solution. Okay, so now if we draw our table of initial table of this problem, so here we just write initial table, and similarly you solve that problem by using same concept. So here this is Cj, and here that is B, the solution values of basic variable, and the variables are x1, x2, and here s1, s2, and s3, s1, s2, and s3, and one artificial variable. And cost of this is 5, here 1, here 0, 0, 0, and here minus m due to problem of maximization. And here basic feasible solution are s1, and here this is a1 and s3. So here s1, a1, and s3, the values are 25, or a1 is 5. Okay, when this a1 value is equal to 3 here, this is 3, not 5, this is 3. So this is 3 and this is 5. Okay, and the cost is 0, minus m, and 0. So this is the problem. Okay, और एक है आपके डुअल सिंटेक्स मेथड की है। डुअल सिंटेक्स मेथड में हम क्या करते हैं कि यहाँ पे हम ये वैल्यूज का नेगेटिव हो जाए। ओके, ये अगर नेगेटिव है तो उसको हम सॉल्व करते हैं बाय यूजिंग डुअल सिंपलेक्स मेथड। ओके, तो वो भी मेथड है। कितना पढ़ेंगे वो तो सब सोल्यूशन में तो सब पढ़ाई होगा अभी। So first equation is 5x1 2x2 1s1 and rest are 0. Second one is 1x1 minus s2 plus a1, rest are 0. Okay. Third one is x2 plus s3, rest are 0. So this is your matrix. Okay, so now you have to compute what is the value of z here. So z equals to, what is the value of z here? So here x1 is 0, x2 is 0, s1 value is 20, but 0 into that, and 0 into s2, s2 is again 0, and here 0 into s3, so here simply minus m e1. So this value is minus 3m. This value is minus 3m. Okay, so now we find out what is the value of z. So multiply the 0, this is minus m, this is minus m. You multiply here, this is 0. You multiply here, this is again 0. Multiply here, minus m plus minus 1, this is plus m. Here this is 0, here minus m. Okay. So what is the value of cj minus zj? 5 minus minus, this is 5, this is m plus 5 here. Okay, and this value is x2 quotient is 1, this is simply 1, and here 0, here minus m, here 0, and this is 0. Okay, so which one is largest positive? So this is negative one, and n is large, and n is large. So here, if we take the m of order of the, this is 5, and this, so we take here m of order, next order this is 10. Okay, 10, but this is unit one space. Okay, here will be this is 5. So we take the n is large. Suppose if the n is suppose 10 here, so this becomes 10 plus n, that is oh, and there is only one positive. There is 1 and 2. Only 2 members are positive. So we take the largest positive. So that's why here this is the largest positive. So this one is largest positive. So this is largest positive. Okay, so this means this x1 is entered into the basis. X1 is entered to basis. So now you have to find the minimum ratio. So what is the minimum ratio? The minimum ratio, that is xb for x1, and this equals to 20 over 5, and this is 3 over 1, and this is 0, so no need to type here. This is 5 and this is 3. So which one is minimum? So this is minimum. Okay, so this is minimum, and this corresponds to which variable? This corresponds to a1. Okay, so that's why this is your key element, and this is by chance this is 1. So no need to operate here to become that key element is already 1. So we only use the e operator in first for first row, that is 5. So we take this minus of 1 by 5 of that. Okay, so this means r1 is, you take r1 is r1 minus 5 of r2. Okay, so for that you make this is 0. Okay, and this a1 is removed from this basis, and x1 will enter. Okay. So this is leave the solution, and here this x1 is enter into the solution, into the basis. ओके, तो आप ऐसे ही इसे कर लें, ये आपका इंटर हो जाएगा यहाँ, तो यहाँ पे आप x1 लिख दोगे। ओके, और इसको फिर आप सॉल्व कर लें। तो आपकी अगर मेन मेरा ये कहना था कि मैक्सिमाइजेशन प्रॉब्लम है तो हम यहाँ पे माइनस कर लेंगे, और यहाँ पे सीजे माइनस देखो तो हम लार्जेस्ट पॉजिटिव सर्च करेंगे। ओके, और अगर हमारी मिनिमाइजेशन प्रॉब्लम है तो हम यहाँ पे प्लस में रखेंगे, और हम यहाँ पे लार्जेस्ट निगेटिव लेंगे। ओके, तो आइदर मैक्सिमाइजेशन प्रॉब्लम हो या मिनिमाइजेशन प्रॉब्लम हो, तो उसके लिए हमने आपको एक फ्लो चार्ट भी दे रखा है। तो आइदर आप बिग एम मेथड से करो या फिर आर्टिफिशियल वेरिएबल अगर न्यूमेरिकल में है ही नहीं आर्टिफिशियल वेरिएबल, तो आप ऐसे ही अगर सॉल्व करना है, आइदर प्रॉब्लम इज मैक्सिमाइजेशन और मिनिमाइजेशन, तो आप उसको अगर आपकी मिनिमाइजेशन प्रॉब्लम है, आर्टिफिशियल वेरिएबल को जरूरत ही नहीं है, तो आप सिंपली सीजे माइनस जेजे को आप मिनिमाइजेशन में लार्जेस्ट नेगेटिव देखिए और मैक्सिमाइजेशन में आपको लार्जेस्ट पॉजिटिव देखना है। तो हम ज़्यादातर कोशिश करते हैं हम मिनिमाइजेशन प्रॉब्लम की तरह ही करने की, बिकॉज इन ऑप्टिमाइजेशन वी हैव टू reduce our uh, uh, because अभी आपने जितने भी टेक्निक्स पढ़ा उसमें आपको मिनिमम पॉइंट ही आपको लोकल मिनिमा ही निकालना था। ज़्यादातर केसेस में हम मिनिमाइजेशन प्रॉब्लम ही करते हैं, बट मैक्सिमाइजेशन भी फिजिबल है ऑप्टिमाइजेशन में, बिकॉज वी हैव टू मैक्सिमाइज आवर प्रॉफिट एंड मिनिमाइज आवर लॉस। ओके, सो दैट्स व्हाई देयर आर टू टाइप्स ऑफ प्रॉब्लम इन ऑप्टिमाइजेशन। ओके, तो ये आपके सिंप्लेक्स मेथड के जनरल मेथड्स हैं, और भी मेथड्स हैं, रिवाइज सिंप्लेक्स मेथड्स हैं, ओके, डुअल सिंप्लेक्स मेथड है, बहुत से अभी और भी चीज़ें हैं, पर उतनी डिटेल हमें यहाँ करना नहीं है। तो इतना ही करते हैं। कल हम नॉन लीनियर ऑप्टिमाइजेशन प्रॉब्लम पे जाएंगे, वहाँ पे हम कल बोथ मेथड नॉन लीनियर प्रॉब्लम सॉल्व करेंगे और वहाँ पे हम सिंप्लेक्स मेथड को यूज़ करना है। दैट्स व्हाई वी डू दिस सिंप्लेक्स मेथड, और लीनियर प्रोग्रामिंग प्रॉब्लम में हम सिंप्लेक्स मेथड हम यूज़ करते हैं, और ये काफ़ी जगह यूज़ होते हैं सिंप्लेक्स एल्गोरिदम आपके, तो इसलिए आपके ये थोड़ा सा इम्पोर्टेंट था सिंप्लेक्स मेथड आपके लीनियर ऑप्टिमाइजेशन में। ये आपके कवर भी कर रहा है लीनियर ऑप्टिमाइजेशन को, और प्लस ये थोड़ा सा नॉन लीनियर में भी आप इसका यूज़ करते हैं, इसलिए ये थोड़ा सा इम्पोर्टेंट है। ओके, तो बहुत ज़्यादा हम डिटेल में हम लीनियर प्रोग्रामिंग में हम नहीं जा रहे हैं कि वहाँ पे हम सारी चीज़ें बताएं। हाँ, डुअल सिंप्लेक्स भी बताते हैं, तो आपको डुअल क्या होते हैं, प्राइमल डुअल क्या होते हैं, कैसे लिखते हैं, किस प्राइमल का डुअल क्या होता है, डुअल का डुअल हमारा प्राइमल होता है, ये सारी चीज़ें। ओके, उसके बाद फिर हम इंटीजर प्रोग्रामिंग पर भी हम जाते हैं, उसको भी थोड़ा सॉल्व करते हैं। उसके बाद फिर हम जो है गेम प्रोग्रामिंग को भी हम लीनियर प्रोग्रामिंग मेथड से भी सॉल्व करते हैं। वहाँ पे मिनी मैक्स, मैक्सिमिन, ये सारे कॉन्सेप्ट्स हैं, वैल्यू ऑफ मीन क्या होता है, सैडल पॉइंट क्या होता है, ये सारी चीज़ें भी आप देख सकते हो। ठीक है, हालांकि सब सिलेबस में नहीं है, सिलेबस में नहीं है, और आप ट्रांसपोर्टेशन प्रॉब्लम भी पढ़ा होगा, असाइनमेंट प्रॉब्लम भी पढ़ी होगी, ये सारी चीज़ें हैं, लेकिन ये सारी चीज़ें आपकी इस इंटायर सिलेबस में नहीं है। सिर्फ लीनियर प्रोग्रामिंग प्रॉब्लम दैट इज फॉर ग्राफिकल सॉल्यूशंस, और हम कैसे हम उस प्रॉब्लम को हम कैसे मैथमेटिकल फॉर्मुलेशन करेंगे, कैसे उसको हम सिंप्लेक्स मेथड से सॉल्व करेंगे, और सिंप्लेक्स मेथड हम कैसे नॉन लीनियर प्रोग्रामिंग को भी सॉल्व करने में यूज़ करेंगे। बस यहीं तक आपका ये है। तो कल आपकी लास्ट क्लास है जिसमें हम नॉन लीनियर में सिंप्लेक्स मेथड के यूज़ बताएंगे। बस इतना ही आप करिए, और इसके अलावा की जरूरत नहीं है कुछ। हम आपके व्हाट्सएप ग्रुप पे हम आपको नोट्स प्रोवाइड करते रहेंगे, जिसमें हाउ टू सॉल्व लीनियर प्रोग्रामिंग प्रॉब्लम और ट्रांसपोर्टेशन प्रॉब्लम, गेम प्रॉब्लम बाय यूजिंग मैटलैब। ओके, तो वो सारी चीज़ें हम आपके व्हाट्सएप ग्रुप पे हम सप्लाई करते हैं। ओके, तो आज के लिए हम इतना ही करते हैं। थैंक यू।